And I'm a senior. I'm from Lansingburg High School.
And I'm Vanessa, and I'm also a senior, and I'm also from Lansingburg High School.
And today we're going to tell you guys about circuits. And we're actually going to build a circuit for you. So basically a circuit is just an electricity traveling in a closed path.
So the basic idea of a circuit is that it allows for electricity to go to your homes. That's the basic idea. So when you flick a switch, you turn on the lights, or when you're even running your oven, you're able to get electricity, which is what turns everything on in your house.
And there are two different types of circuits. There is a series circuit, as you can see, and there's a parallel circuit. And right now I'm going to show you the basics of a parallel circuit. So on a parallel circuit, the current can be broken up. So instead of having one full current, you have one current that can go here, but you can also have a current that goes here and here. And it all starts as one current, and what it's going to do is it'll split at this point, and it can go either here or it can continue going straight. Once it gets to this point, it can also split and go here. So basically, if this equals A, and this is 1, and this is 2, A equals 1 plus 2. And that's how the current works in a parallel circuit. The good part of a parallel circuit is that if one light bulb was to go out, the other two would still stay lit. And can you guys think of any examples of a circuit that's in parallel?
And hopefully we have children to say, oh, well, like our homes and blah, 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 cute children.
And then
Okay, so now we'll do series. So the main part of a series is that the flow of electrons, or your current, all goes in one direction, and it's always continuous. So we have it going from positive, and it hits this light, and it keeps going. It goes to this light, and it keeps going, and it keeps going. So you never have the breakup like you do in parallel. So basically the main point of a series is that you just have one current throughout the entire. So it's always going to be the same wherever you go for each light. So the one problem with this is that if one light bulb goes out, the current or the flowing of electrons will completely stop, and all of the lights will go out. So that's the one problem that we have with a series. That's also different from a parallel. So can any of you possibly think of one example that you would use a series circuit in? And hopefully children will say, like Christmas lights.
If I can spell Christmas, that will be the goal.
Right, very good. So in Christmas lights, if one light goes out, they all go out. So eventually you're going to have to try to find which one to replace, which is what's so difficult about the series. But it's still useful. We still use it. So now what we have for you is an activity to kind of show you how circuits work and what they actually look like. In this case, we're going to use Play-Doh.
So the green is our conductive, which means it creates electricity.
And the pink is our insulating, which means that it stops the flows of electrons. So it's a poor conductor of electricity.
Do we have one piece of Play-Doh?
And now after we're done setting this up, if we could have a volunteer, and we don't have a volunteer right now, but make do. So we have one conductive piece here, the insulating piece in the middle.
And another conducting piece. And the important part is that the two conductive pieces do not touch each other.
Right. Two green can't touch. So first we'll show you what a simple circuit looks like. So now this is the longer piece, so we'll attach this light right in here and this right in here.
It's very important that when you hook it to your battery source, the positive always goes with the positive of the battery.
So now this is our DC power supply, which all you guys need to know is that it allows for electricity to basically flow. Do you want to hook that one in there? And as you can see, it lights. So this is an example of a simple circuit. So now what we're going to do is we're going to show you what a parallel looks like.
So, as you see in the drawing, the parallels are just connected as more than one. So you
in
do
this
the same thing. This is the longer side. And as you can see, that lights up.
Right. It's a little dim, but that's because, remember, we're sharing our current. So because of that, the lights will get a little bit dimmer as we go on. So that is a parallel. So now let's show you a series. So for this one, we're going to need more pieces of our conductive and insulating.
So you said earlier that conductive creates electricity. Why do you need a battery? Is the conductive really creating electricity?
It's allowing it to flow.
Did I say that for insulating too? Okay. So now we have our pretty little series circuit, and now we're going to put the lights in. So this is the longer, shorter. So as you can see, remember that for a series, the entire current is always shared. So it's going to keep flowing. So that's why these are all going to be connected like this. So. So there goes the one. And for this, the only reason why we're using this is just because we need just a little bit more power for it. And as you can see, both are lit. So those are parallel and series circuits.
So that is basically the idea between simple circuits and the series and the parallel. Now, something that is becoming more popular is what's called smart lighting, and that is being able to control the way that you use your lighting.
Right. And the biggest way that we control the lighting is through computers, so being able to control them digitally. So one of the basic examples of smart lighting is the simplest example that we probably could come up. There's a few. Is if you were to walk into your room and the lights were able to sense motion, so then the lights will turn on. So if they see that there's movement, the lights will automatically turn on. Now let's say you're sitting for a while, or you even leave the room. Well, after that, the lights will sense that there hasn't been motion for a certain amount of time, and they'll turn off.
Another example of smart lighting would be if you're an elderly person, many of them have to keep lights on all night in their houses because when they have to get up to go to the bathroom, they can't see very well. A way that we could use smart lighting is that when they wake up and step on the floor would light up as they walk, and each time it would stop lighting up once they move from that area.
Right.
So what we have for you today is a little activity about your classroom, and we're going to see where you think smart lighting would be most useful in your classroom.
Right. So we'll hand out a sheet of paper to all of you, and we hand them out to everybody. And basically, let's read the top page of the directions. So on the following pages, answer the questions stated below. So take a colored pencil, which are up here, and draw an X in the areas you believe smart lighting would be most useful throughout your classroom. So as you're doing this activity and as you're drawing the lights, think about these questions. Where would the lights be most useful? And where in your classroom does your class spend the most time? So is it in the reading area? Is it in maybe by the chalkboard? Would you want a light to light up the chalkboard? So think about where would be most useful and where you guys spend the most time. And then we'll let you do that, and then we'll regroup after.
Think about also where the windows are located in your classroom, because if you are in your classroom during the day, which is when the sun is out, do you need lighting close to there, or do you need lighting in the areas that are farther away from the window?
So then we let the little kitties do that. And then we ask for volunteers to show us maybe a few volunteers to see, I'll do that. So if a few volunteers want to come up and maybe show us where they thought was best to put the lights, and then we'll look at that, and hopefully they get the idea that they put them near the desks and put them by the chalkboards and whatnot. And then after that we tell them they're very good, and maybe we'll give them candy or something, maybe if they're lucky. Maybe we'll let them taste the Play-Doh, it's up to them. And that's our presentation.